In order to improve the stability, we need to work on radius, differences in densities, thickness, and gravity. Fine. So in formulation of suspensions, we have two types: flocculated suspensions and deflocculated suspensions, or non-flocculated suspensions. So flocculated suspensions are more stable when compared to non-flocculated suspensions because they form loose floccules. These loose floccules easily redisperse on moderate shaking, and they don't form a hard and dense cake. So flocculating suspension is ideal. So we need to add a flocculating agent while preparing the suspension. So there are three different type of flocculating agents we commonly use: surfactants, polymers, and electrolytes. So what does these flocculating agents do? They bring closer these solid insoluble size reduced drug particles and help in formation of loose aggregates which can be redispersed on gentle shaking. Next thing which we add in formulation of suspension is thickening agents. So this addition of thickening agent will help us in increasing the viscosity in the suspensions or continuous phase of the suspension. And the second thing is it helps in decreasing the differences in densities. It helps in increasing the density of the continuous phase. So there are four different types of thickening agents. We use natural thickening agents, semi-synthetic thickening agents, inorganic thickening agents, and synthetic thickening agents. In natural thickening agents, we have examples of gum acacia, compound tragacanth powder, starch, and sodium alginate. In semi-synthetic type of thickening agents, we have methyl cellulose, sodium carboxymethyl cellulose, microcrystalline cellulose. In inorganic type of thickening agents, we have clay, aluminum hydroxide, and in synthetic, we have carbomuds and colloidal silica. Then we add wettening agent, then we add preservatives, and then we add organoleptic additives in order to improve the palatability of the suspension. Right. Now we will try to understand what are the different techniques to study the stability of emulsions. Basically, there are four different methods to identify the stability of suspensions. Number one is sedimentation method. In sedimentation method, what we do is we will try to measure sedimentation volume. We will take a measuring cylinder, we will add a suspension to it, and we will keep it aside for some time without disturbing it. Then we will measure the volume of sedimentation. We will take the measurements before sedimentation and after sedimentation by a simple formula, the rate of sedimentation. By taking the ratio of ultimate height by initial height, we can get sedimentation volume. So this will help us in identifying the stability of suspension. Second thing, we can even check the redispersibility of the suspension. We basically take the sedimented suspension and we will gently shake it and try to find out what is the redispersibility, whether your suspension is being redispersed with gentle shaking or you need to work more on it or not. So easy redispersibility is the good sign of the suspension stability. Then you have rheological method. Rheology is basically study of viscosity. So here you will measure the viscosity of the prepared suspension at different time intervals and at different positions. For this thing, basically you use a good viscometer and you will insert it in the formulation and you will check the viscosity at different heights at different times. Basically, decrease in viscosity will affect the stability. If the viscosity of the formulation is good, then the stability of the formulation will be fine depending on time. And the second thing, when you are measuring the viscosity at different positions, what's happening there, if the viscosity is not uniform in all level in your suspension completely, then there is a chance of sedimentation. See, at the top layers viscosity is decreased, and at middle layers viscosity is more, and at the bottom layer viscosity is less. It means your particles are sedimenting and they reached at the middle of the point. Then after some time, if the viscosity of the formulation is less in the in upper layers and it's more at the bottom layer, then it means your particles are sedimented and they are gathering there and the cake is being formed. It helps us in studying the aging of the suspensions, and it helps in identifying the rate of sedimentation. So rheological factor is very important to identify the viscosity of the suspension at different time intervals and at different positions. Helps us and gives us very important data which helps us in understanding rate of sedimentation. Next important parameter or the method of identifying the stability of suspension is electrokinetic method. In electrokinetic method, basically we will measure the zeta potential. What is the zeta potential? Zeta potential is the surface charge of the particle. It's a potential difference between surface of the particle to the electrically neutral region. So determination of zeta potential or the surface electric charge is helpful in finding out stability of an emulsion. Zeta potential Zeta potential is very important. If the zeta potential is 50 millielectric volts, then it produces very stable emulsion due to controlled flocculation. So how can you measure it? You can measure the zeta potential by using zeta sizer, or you can measure the migration velocity of particles using electrophoretic method. What we do in electrophoretic method, we basically add an opposite charge electrolyte, then we will see the migration of these particles towards that electrolyte. We will measure that velocity and we can find out how much charge is there on the particles. So this will help us in identifying the stability of the emulsion, and the data is very much useful in identifying, in studying the rate of sedimentation. Then we have another method, Microscopic method. In this method we will measure the particle size of the suspension. If the particle size is growing, it means the stability of suspension is decreasing. As we discussed earlier in Stokes law, that the particle size, the radius of the particle is very important factor which governs the rate of stability. In some suspensions, due to crystal growth mechanism and due to coming of these particles closer, there is a chance of growth of particle size. If the growth of particle size, if the size of the particle increases, then it leads to the formation of lumps, which can again leads to the formation of cakes. So basically we have already discussed that the particle, if the particle size is smaller, the rate of sedimentation will be slower. If the particle size grows, maybe due to the crystal growth mechanism or maybe due to the other reasons, then what happens, the rate of sedimentation increases, cake formation increases, and lumps formation increases. So any change in the particle size with reference to time will provide us very useful data regarding stability. So in order to measure the particle size, we have different methods like microscopic method. In microscopic method, basically what we will do, we'll take a drop of suspension, then we will focus it on the microscope and we'll try to measure the particle size. Then after some time we will take the next drop of suspension, we will measure using the eyepiece micrometer and stage micrometer. We can easily measure the average particle size and we can identify whether the particle size is growing or not. Then even we have in micromeritic method, we have another method using Anderson pipette method. By using Anderson pipette method also we can identify whether the particle size is growing or not. So identifying the growth of particle size, identifying the charge present on the surface of the particle, then measuring the viscosity and the changes in the viscosity, and identifying the sedimentation volume. These four are the different factors which helps us in studying the sedimentation, which helps in studying the rate of sedimentation, and which helps us in identifying the stability of suspensions. So in order to overcome the stability issues, as we discussed earlier, in order to improve the viscosity of the continuous phase, we are going to add the thickening agents, suspending agents. In order to decrease the differences in densities, again thickening agents are going to help us. In order to improve the redispersibility, we are going to add flocculating agents to make it into the flocculated suspension. So each and every factor which we studied affects the rate of sedimentation can be addressed in formulation of the suspension. So this is about the stability of suspensions. In coming classes we will discuss about the other formulation parameters and other formulations. Thank you for watching this video.